will give the intro. After that, you can process.
Okay, sir. Okay, thank you, sir.
Okay, sir. Recording started. Saravanan, sir, please go ahead.
Okay, start pannu. Okay, sir. Yeah, good evening to one and all. Now, we are entering into the session number 8. Atal sponsored 6 days online faculty development program in the title of Next Generation Green Energy Powered Electric Vehicle and Renewable Energy Integration using Solar Microgrids. Now, this is time to welcome our session speaker, Dr. N. Shanmugasundaram, sir. Sir is presently working as professor in Department of Electrical and Electronics Engineering, Wales Institute of Science and Technology and Advanced Studies, Tamil Nadu. Sir has completed BE Electrical and Electronics Engineering from Mana University, Chennai, and Sir has completed ME degree Power Electronics and Industrial Drives from Satyabama University, and Sir has received a PhD degree in Electrical Engineering from Mana University, Chennai. Currently, Sir serves as a professor in the Department of Electrical and Electronics Engineering, Wales University. Sir is having 18 years of teaching experience and 4 years of industrial experience in Tamil Nadu. He brings a wealth of knowledge and expertise to his role. His contribution to research and substantial, with over 64 research papers published, including 5 papers in ACI Indexed Journal and 26 papers in Scopus Indexed Journal and 34 in other indexed journal. Additionally, Sir has authored 3 textbooks in electrical engineering and holds 4 patents with 3 patents granted. Sir is actively involved in mentoring and guiding the next generation of scholars, currently supervising 5 PhD research scholars, with 3 already awarded their PhD degree. His research interest with the span various areas within electrical engineering, including electrical machines and control, EV control and charging, power converters, and power cable modeling. His dedication to both academy and research underscore his commitment to advancing the field of electrical engineering. Now, Sir will give the expert talk on in the topic of wind power and smart grid technologies for sustainable developments. Sir, Shanmugasundaram, sir.
Thank you, Professor. Thank you, Professor, for the given introduction about myself. I will start the programs.
With pleasure, sir.
Thank you, sir. Thank you, sir. Professor, screen visible?
Visible only, sir. Continue.
Okay, Professor.
You just check it, sir. It is movable or not. Then we'll.
Okay,
Next
Professor.
slide.
Okay.
Next slide.
Okay, Professor. Is it movable?
Yes, sir. Next slide. Move
Arrow down. Down arrow, Professor. Okay. Or left arrow.
Okay. Yes?
Yeah.
Now it's okay, sir. Now it's okay.
Okay. Please.
Okay, good evening to all. I will give a small introduction about is the wind power, smart grid technology for sustainable development. And I am Dr. N. Shanmugasundaram, Professor, Department of EEE, Vistas. Today I'll discuss about that the smart grid. Smart grid differ from traditional grids, distributed energy resource, and smart grid networks. What are the challenges in smart grid, and what are the measures from challenges and smart grid, AC smart grid, features of AC smart grids, savings of power with smart grid technology and IoT. So DC smart grid and DC smart grid in electricity generation and distribution of supply, and another followed by data flow in smart grid and smart grid hardware system. What are the different elements and the stakeholder of smart grid system? In the new technology, this is a blockchain and technology we are discussing, and also followed by smart grid environmental and impact of sustainability, impact and sustainability, integration of artificial intelligence, and let us research area we can concentrate for the smart grid and AC smart grid also.
Sir, Shanmugasundaram, sir.
Sir, this is connected. The screen is
Screen present not available, sir.
not
One
available.
second, sir. 1 second, share, sir.
Okay. Yes, sir.
Now it's okay, sir. Sir, if possible, full screen பண்ண முடியுமா?
Okay, sir. Okay, proceed. Smart grid. This is a hybrid smart grid. And what are the components of smart grid? The different type of components are employed for smart grid. The energy resource, smart technology, energy management system, communication networks, and microgrid. These different features of smart grids are employed: flexibility, sustainability, and efficiency. Now, there is nothing but what is smart grid? Smart grid is an advanced electricity network that integrates modern technology to improve the generation, distribution, and the consumption of electricity. It combines traditional grids infrastructure with the digital communication and automation and the data acquisition system, enabling the real-time employment monitoring and the efficient energy management system. While we are minimizing the cost and maintaining the stability and the reliability of the grid. This is nothing but what is hybrid? What is hybrid smart grid? This hybrid smart grid refers the latest technology and the generation and the distribution system that integrates the different multiple energy generation sources. These are like that. These are renewable energy, conventional energy, and the energy storage for the application of for transmission and distribution. With the smart technology to optimize the electricity distribution, to improve the reliability and also reduce the environmental impact. It incorporates advanced monitoring, controls, and automation technology for efficient energy management system. These are smart grid different from traditional grids. These are different aspects are find out. These are differ from traditional grids. Communication, energy resource, general sources, fault detection, and the consumer role and the efficiency. The different parameters are analyzed differ from smart grid and a differential traditional grid. These are nothing but these are traditional grids. We are the communication between one to one. there is a one-way communication. That is nothing but the consumer to utility and utility to consumer only, one-way communication only. We are this only for utility to consumer. And then in case of smart grid system, this is a two-way communication. Utility to consumer and the consumer to utility for data collection and the data monitoring and different aspects. So the another important point, the energy sources in a traditional grids are centralized. That is nothing but fossil fuels they are used for this traditional grid system. In case of we are using the smart grid system, decentralized, that is including renewable energy, renewable sources are applicable for smart grid system. In case of fault detection, we are using for this traditional grids reactive applications. But in case of smart grid system, this is a protective and automated system are employed for fault detection. In this smart grid system, the fault is immediately find out and given the immediate response to the consumer. In case of consumer role, these aspects are the different and the passive for traditional grids and then smart grid in case of active system. The efficiency is normal, minimum efficiency for traditional grid. In case of smart grid system, we are used for higher efficiency. Higher efficiency comparing the traditional grid. So far, where this distributed energy resource. What is meant by distributed energy resource? Energy includes the technology like solar panel, wind turbine, energy storage system. There is a battery electric vehicles and a demand for responsive capability of
not moving.
Hello?
Slides
Sir,
are
excuse
not
me,
moving.
sir.
Sir?
Slides are not moving, sir.
Oh,
It's in the first slide.
okay. Oh, first slides. Now, okay.
Yes, sir.
On the mobile,
Yes, sir.
the next slide is seen.
Now, presently, fifth slide showing.
That is a smart grid.
Yes, sir.
Okay. The comparison between the smart grid and the traditional grids is the aspects of communications, energy sources, fault detections, and consumer rules, and the efficiency. The different type of aspects are followed by these comparisons between traditional grids and smart grids. Normal, in general case, the traditional grids are communication between only for utility to consumer only. This, in case of the smart grid system, we are used for both the data communication between utility and the consumer. This in case of any function, any malfunction, any there is a usage, and this data will be communicated to utility from the consumer. So in case of energy sources, is centralized for traditional grids, nothing but the fossil fuels. And then in case of smart grid system, there's different kind of energy resource are available. That is like the renewable energy. That is nothing but solar, wind, thermal. That is everything. There is a decentralized includes all. For in case of fault detections, this in case of traditional system, this is the reactive one. But in case of smart grid system, protective and automated, everything automations. That is like some different software are employed for fault detection and fault solution also immediately given to the consumer. In case of the consumer role is the passive, and then in case of smart grid system, the active. This comparing the efficiency, traditional grid is higher. There is a minimum values, and in case of smart grid system, this efficiency is higher comparing the traditional grid system. These distributed energy resources are this main impact and impact of reflecting the smart grid system. The different combinations are analyzed. One for technology, a function, and a distributed generalized using renewable technology, and another key benefits of this distributed energy sources. Nothing but the technology, comparing the technology, these are the different kind of form of energy resource are used for solar panels, wind turbine, energy storage batteries, and electric vehicles, and a demand the response for capability and the different technology are employed for this distributed energy resource. In case of functioning, but generate, store, and manage the electricity to this and also improve the grid efficiency and sustainability also. The distributed generalized renewable technologies that is nothing but small scale integration, and that is a generation of located close to the point of use. In case of the demand on renewable energy source, including the solar, wind
The slide is
energy.
not changing.
Yes.
The slide has not moved, sir.
Now, sir. Now, sir.
It is in 5th slide.
Now.
No, sir.
Now moving.
Yeah, now
And this.
sixth slide.
Hello.
Now sixth slide, sir.
Distributed energy resource.
Yes, sir.
But this go for full screen. This slide not changing.
Okay. Do one thing, sir. Just already you forwarded PPT, right?
Yes, sir.
Can I play that one?
No, this small change. Right?
Sir, okay. You carry on. No need full screen. You just carry on this one.
Okay, sir.
Okay, Pro. So please carry on. Go ahead.
Just a minute.
Okay, sir. Okay.
Take your time, Pro. Sir. No issues.
Okay.
Pro, sir, do one thing. Share the PPT to me. I will share the screen. Very simple. Okay. Saravanan, sir, please mute your
Sir.
Noise coming from your end. Sanmugha Sundaram, sir. Yeah, please. We can see your slides, sir. Please.
Okay,
yeah.
sir.
Yeah, please. Please move. Next slide. Down
Yes,
arrow,
sir.
bro. Down
Huh?
arrow. No. Down
Yes,
arrow.
sir.
First slideல இருக்கு ப்ரோ சார். டவுன் பண்ணுங்க. கீபேட்ல டவுன் பண்ணுங்க. கீபோர்ட். இல்லனா ரைட் ட்ரை பண்ணுங்க. ரைட் ஆர் டவுன், பேஜ் டவுன். யா. நவ மூவிங். Sanmugha Sundaram, sir. Pro, sir. Yes, visible. Second slide, please. Yeah, moving processor. Third slide.
Yes, Professor. Moving.
Yes, professor. Second slide only. You can down click the down arrow. Yeah, moving now. Moving.
Moving. Yes.
Now moving, professor. Please use the same control, professor.
Okay. Okay. Okay.
Yeah.
Okay. Thank you.
Exact. Excellent. Moving.
Okay. Okay.
Please
Okay.
go ahead.
Distributed energy resource is different methods we are employed for distributed energy resource. This is the main function. The technology point of view is a solar, wind turbines, energy storage systems, and the electric vehicles applications, demand response from capabilities. This technology we are employing. And normally it's discussed the function of the distributed energy resource. This is generate, store, or manage the electricity of the electric generation of power, and also improve the grid efficiency and also sustainability, also to improve the using the distributed energy resource. This is a distributed energy generation using the renewable technology. This is nothing but this is a small scale energy generation system located close to the point of view we can use. And alternatively, we have the demand of renewable energy resource, that is including the solar, wind, turbine, biomass, and the hydropower also. These are included in the distributed energy resource for point of view. Then the different key benefits are utilized for the distributed energy resource, and the optimal independently, and that is the traditional and alongside the grid. They enhance the energy efficiency and also reduce the transmission losses, and that is a generation also. Support the sustainable energy object also. There is a key benefits are employed for this one. And another point of view, the smart grid networks. Smart grid networks. This figure indicates the different form of energy storage, and there is a generation also, where the a diagrammatic representation. They transfer the power system networks utilities are poised to move from the traditional power system to highly flexible and secure one, and nothing but the green power system also, using the integrated two-way communication and advanced control technology we are provided for the smart grid network system. This the flexibility and secure green power system. This is energy generations, nothing but include the conventional plants, wind farms, and the solar farms, or these different energy generation system are employed. In case of transmission system, this is transport electricity from generation to distribution. In case of the storage system, this is nothing but source of surplus energy for big generation point of view. This storage energy can be stored from surplus energy. In case of electric vehicles, the act as the energy consumes and the storage units for the smart grid system. This is also microgrid. Local grid integrating with the renewable energy for reliability or applications, and end user. This is nothing but the different kind of consumers are used for this. There is a commercial, residential, and industrial application, and solar industrial application also. In case of circular flow, the dynamic integration of energy, and it's nothing but generations, storage, and the consumption of electric power. Also, these are the different energy part of view. The key this generation, other than nothing but energy storage, electric vehicles, other distributions, and the main function of the smart grid system. The diagrammatic representation, the different main functions are included in this smart grid system. I think the monitoring and management, power management. What is the monitoring and power management? This is nothing but real-time monitoring of electrical supply, demand across the grid. The enables utility to detect fault and also inefficiency more quickly and accurately. These are monitoring and power also management using the main important function of the smart grid system. The demand response function, they adjust the electricity usage during the big demand by communicating with the consumers and also incentive they reduce the voltage. Nothing but they reduce the strain of the grid system. And also this nothing but prevent blackouts and also lower energy cost also blackout. Then the storage system is another one important main function. There's a support the energy storage system that mathematics are used for employed for batteries to store the excess energy for later uses to balance supply and demand, especially when renewable energy productions and fluctuations of the power supply also. This is nothing but managed for energy storage system. This is a distributed energy resource management. They integrate and manage the distributed energy sources, that is decentralized production, enhance the flexibility and efficiency and the energy efficiency to monitor and controls. There's frequently we are changing the we are frequently monitoring and collecting the efficiency to report to the main grid. And also helps identify and also reduce the losses during the transmission and the distributions. Now the cost also saves, minimize the there is an environmental impact. There is a impact also. These different functions, and then main functions. What are the challenges? The different challenges are facing with the smart grid system. This is nothing but the inadequate grid infrastructure, energy storage. During this energy storage system, we are facing some challenges. Database management, this to collect the data and send the data to. We are facing the challenges and the cyber security data. This monitoring and collecting the data, cyber security and high initial. The cost of high initial investment and different policy and regulations are every year. There is a change for this monitoring the installing the smart grid system and a lack of awareness to the consumers. These different key challenges are facing. This initially first we are the cost wise initial cost and the higher cost. The smart once we are installed the smart grid, this is nothing but higher initial cost. This the smart grid infrastructure such as advanced sensor, different based on the level of based on the new initial technology. This advanced sensor can be applied. So for the initial cost has increased. That is smart meters requires significant investment for initial cost. How to challenges? How to measures to these initials? So far, in India, once we are installed the smart grid system, there are different government incentives and subsidies are available in this grid installations. There is a government of India has announced some subsidies to the new install in the smart grid in the private government. There is a public and private partnership also to share the financial burden. So far, and then cyber security risk. Cybersecurity risk, the challenges, nothing but this increase the digital system to so far make the grid valuable and cyber attacks. So for data breaches and hacking also some for this one. Now, how to measure? How to measure this? Implement robot cyber security system framework and encryption also protocols can be applied, and then conduct the regular security audits and penetration testing, develop the threats detection and response of the system. So The integration of the renewable energy, the consumer resistance, and the data management's complexity also we are one of the biggest challenges. So far, the reliability and the scalability and the regulatory and the policy barriers also one of the biggest challenges under this one. And there's some technical skill gap between the infrastructure, but nothing but aging in the infrastructure. So for this next important regulatory and policy barriers are one of the biggest key challenges is nothing but the lack of clear policies and regulation for implementing the smart grid can slow progress. There's a lack of awareness, also lack of policy, clear policy not available to install there is a smart grid system. There is the how to measures is nothing but is audible, sir?
Yes, Professor, please.
This is nothing but the first establish the comprehensive policies to encourage the smart grid and adaptations. Set the clear regulatory framework for energy tradings and renewable integration and promote the international collaboration with the share the best practice to measures. This is some another important point of view. The technical skill gap is one of the important challenges. So they said so far they need a skilled professional to design, implement, and maintain the smart grid system in the perfect manner. This is another the important technical point of view. These people are not available this to work in the smart grid system. These are only for few technology oriented people only they are available. So for this lack of skills gap will be arised. And then how to manage, how to measure. This is nothing but this offer specialized training that provided and encourage the program, the different kind of program in awareness of smart grid and what are the technical gap with this awareness technical gap is available and how to challenge, how to install the perfect smart grid system, and then new technology, what are the new technology trends are going on. These are discussed to these giving the training to the technicians. And then the partner with the academic institution to develop the smart grid or related courses also we are ready to provide the and we are given the training to the technical trainer and encourage the knowledge for sharing the through global conference and forums. This is another one main important task. This is the aging infrastructure also. This is another one challenges. Aging infrastructure. Nothing but the world, the outer grid infrastructure for smart technology can be one of the important challenges. This for 10 years back or 20 years back, this system will be not accumulated with this new technology. So far, this is another one aging infrastructure. That is nothing but how to measure. This is a priority upgrades crucial critical areas with the highest impact. Nothing but and the combined smart technology with the existing infrastructure where possible. So for replace inheritance system in face of to minimize the disturbance. So for this important challenges, we are this nothing but this okay. Many grids will be built decades under or this under staying due to the increase the demands and modernizations that is to measuring the modernizations, implementing the smart grid technology for better monitoring controls. This another one aspects. This integration of renewable energy. So for variable and distributed energy sources, nothing but the like the wind, solar. These challenges for balancing the supply and demand. And this variation of the power generation in wind and solar. So balancing supply demand is very difficult. This nothing but to store the surplus energy and enhance the grid flexibility. Energy, so suppose in case of higher summer season, we can store the energy for through battery system to the energy and enhance the grid flexibility. And cyber threats also discussed the valuables cyber attacks due to the increase in the destinations. So now we are go for this safeguarding the grid infrastructure against the cyber attacks. This is nothing but this is measurables one. So for and then conjunctions is the overloading. Now the overloading is very one of the important challenges we are facing the smart grid system. Overloading means that initially some load will be immediately suddenly added. This is we are facing the challenges. So now upgrading the expansion transmission lines to meet the growing the energy demands. And grid stability. And stability also one of the important challenges. The managing the fluctuation and ensuring the stability capability, especially for the decentralized energy sources. So for now, how to measure this? Encouraging the consumer to shift energy basis off and the peak times. This some the response person. So for programs are we are encouraging and the consumer. AC smart grid. AC smart grids, that is nothing but refer modernization of traditional and alternative current electrical grids by integrating the advanced technology like that the sensors, automations, and then communication system to enhance the reliability and the efficiency and the flexibility also. The aim is to enhance the reliability, efficiencies, and then flexibility in the AC smart grid system. In the key components, nothing but these power generations, and then transmission lines, and the energy storage, nothing but distribution networks. This okay. And then what are the advantages? Means is nothing but advantages is enhanced grid reliability. Enhanced grid reliability, that is nothing but this enhanced grid reliability reduce the likelihood and the duration of outage through the automated system. The energy efficiency, to monitor the energy efficiency and then minimize the transmission losses and optimize the energy usage. And then consumer empowerment. Now think that the provides tools for consumer to monitor and control their energy usage for the applications of consumer empowerment. And then the monitoring, real-time monitoring and communications is nothing but we are using for sensor and IoT device to collect the transmit real-time data on grid in this perfectly. The advanced communication protocols enables to dynamic control of power flow and system behaviors. The integrations renewable energy, that is nothing but the seamless integrates now solar, wind, and other renewable sources also integrate with the integrated system. Now this managing the energy production to maintain the grid stability to from the integration system. Demand sides we are managements so incorporate smart meter and demand response program to balance the energy consumption. Improved reliability, there's nothing but quick identify and isolate the fault to reduce the outage. Optimize power distribution to minimize the energy losses also. And that is nothing but the black diagram represent the AC smart grid. This AC smart grid, the different key components are employed. These are smart meters, advanced sensors, and monitoring the system, communication infrastructure, energy storage system, distributed energy, resource resources, and the substation automation, advanced distribution management, renewable energy integrations, high voltage transmission lines, fault detection and isolation system, grid tied inverters. These are main important components are employed for AC smart grid system. These are application point of view, urban energy management system, rural electricians and microgrid supports, integration of electric vehicles, charging infrastructure, renewable energy hub and hybrid power system also. This is the main application of AC smart grid system. What are the features of AC smart grid system? The different kind of features are employed for the future smart grid system: power generation from renewable energy sources, smart sensor and a transmission line, energy storage system, that is nothing but storage batteries, and the automation system. Robotics, now they were used for robotic automation system. So these substations are automated with some robotic system, real-time monitoring and digital dashboards, smart distribution networks, grid communication system, and integration of electric vehicles to charging the infrastructure, and a new electric vehicle charging stations are installed in the nearby AC smart grid system, load balancing for demand management, and self healing capability also is using the AC smart grid features. Savings of power with the smart grid using IoT. This I think the smart grid defined the new you are using IoT technology. IoT technology you are using savings of power with the smart grid IoT. DC smart grids also this one a modernized direct current power distribution network. This is nothing but this these all smart DC smart grids are modernized. They are installed, but few years back, this all sensors and the technology are latest technology are implemented in the DC smart grid system. Incorporate the advanced technology for efficient energy management system also employed for the DC smart grid system. Integrate the renewable energy sources like that solar, wind, also integrate with the new technology, and there is a energy generation also increased using the latest technology, and including the includes the energy storage and battery backup also. This in smart grid business is a better one. And then advantages nothing but key components is the different key components are different key components. Different key components are employed for DC smart grid system. That is power generations, and then nothing but renewable energy sources and the distributed energy sources are main key components of the DC smart grid system. And followed by energy storage also one of the important key components. That is a smart meters and sensor. That is a device. The smart meter and sensor used for device to monitor and a real-time energy flow usage and the system performance for efficient energy storage and management system. Energy storage and generation management system using latest sensor also used for power converters. The high power converters are applied for DC to DC power conversion system to step up and just step down the voltage as the record level of different device and the system also used. The centralized and decentralized softwares are using to optimize the energy flow. That is manage the loads and ensure the grid stability also using for different software used for. And the different kind of loads that is interconnected with the DC smart grid system, the DC powered appliances, lighting device, and HVDC system also interconnected. Industrial, that is nothing but more industrial application like that, motors and machineries and the data centers are interconnected with the DC smart grid system. And there's the advantages, the main advantages of DC smart grid system. Already there's a higher efficiency. There is a reduce the conversion of losses. This is avoiding the AC to DC and the DC to DC transformation. That reducing the losses. So improve the integration. So for connect the DC based renewable source and storage system. So improve the integrations. Stability wise, we are this easily expand the includes and additional energy resource. Our loads are easily expanded and the scalability and stability. Reliability, nothing but this enhance the enhance the fault and ensure the uninterrupted power supply with the intelligent fault detection system. So for improve the reliability also, and support the modern technology. So for facilitate the use of DC based technology like the EV, solar system, and the battery system, the modern technology are integrated with the DC smart grid system. DC grid in electricity generation and distribution of supply. Supply, the generation, transmission, and distributions. The hybrid, in case of hybrid smart grid system, this generation of interconnect with DC grid, and then that is using for renewable energy conversion source and energy storage system. The smart technology and optimize the electricity distribution to improve the reliability and reduce the environmental impact. That is incorporate the advanced monitoring, control, and automation technology for use in hybrid smart grid system. This the hybrid smart grid system is a smart technology IoT device, and IoT device are employed. Advanced metering infrastructure also included in the hybrid smart grid system, and there is a grid automations, automated control system for fault detection and fault balancing, and is employed for this hybrid system. Different communication networks are used for the smart grid system. This enhances and enables the data flow between device, substation, and the controls using for some communication networks are applied. There is a use of protocols like that Zigbee, Wi-Fi, and our powered line, the power line transmission, power line communication also applied for communicate the from sender to utility, that is utility to grid system. And then flexibility also is flexible, the main ability to integrate diverse energy sources for hybrid system. And then better efficiency and utilization and reduce the losses through demand response of mechanism. So these are main applications are the hybrid system is a home appliance and rural communities are employed for hybrid system, and optimization of energy cost and reliability in the industrial sector also. There is a remote location off-grid solution for using for microgrid. So urban areas are the smart grid, that is a hybrid system or hybrid smart grid system are employed, supporting the electric vehicle charging and reducing the peak loads. We are facing some challenges in the hybrid system, hybrid smart grid system. Yeah, the same initial cost for infrastructure and technology integration, cyber security risk due to the increased connectivity. So regulatory and policy hardness, also multi-source energy system, also some challenges, complexity for managing the diverse of energy sources, and this is the main complications. Working of smart grid, this equipped with the computer technology and perform the communications and automations of connectivity. Main components, this nothing but the smart meters, computer system controls, smart appliance, energy management system, and energy storage and power plants. These are interconnected with the smart grid. So far, there's these also some utilization measuring units to measure the current and voltage and high efficiency, to enabling the system monitoring and the dynamic visibility, and also involve the modernization both transmission and distribution circuit requires electronics power controls. There is a power converter. There's a different type of controls are requires to maintain the distribution of proper functioning the grid system. The data flow in smart grid system is another important aspect for discussing this today. It is noted that the smart grid system has the different level and stages, data handling, data acquisition, and data processing, and also take the outputs. The input informations of the smart grid system includes informations on weathers, financial data, utility specific information through GIS, SCADA system, EMS system. The output data is used from the control room display, desktop display, and mobile device for data outputs. And then also there are two type of communication system are employed for smart grid system. They are nothing but the HAN and WAN area, that is a wide area network, and home area networks. The two different kind of communication networks are employed. So for the hand controls connected in-house with the smart device. Home area controls, home area networks are connected with the in-house smart device to smart meters using Zigbee and wired or wireless Ethernet or wireless Bluetooth. Also, these hand controls used for device. On the other hand, this wide area network is bigger and join the smart meters with the companies and the energy appliances system. To this the technology used for WiMAX, that is nothing but wireless communications networks. Or fiber optics networks are employed for data flow for that is a utility to grid utility from the smart grid system. The ICT tools, ICT information communication technology, ICT operation and monitoring and control the data from realize there is higher reliability, that is nothing but economics and efficiency and sustainability to implemented the ICT technology tools. In smart grid system, also the distributed energy delivers under to two-way communication, two-way from electric power as well as to two-way flow from that is information, that is data communications between system to grid to system, and utilities utility to grid. The system facilities and infrastructure balance the electricity supply and demand in smart grid delivers made possible by the incorporation of distributed computing and communications. So for the architectures, this enable to real-time information exchange between the communication networks. The smart grids connect home appliances, that is switching, that is switches, smart meters, transformer, relays, capacitors, banks, and integrated electronic device. Relays and actuators. These are different used for these communication networks. Use applied for communication networks. Elements of stakeholder. Now these are elements of stakeholder. Elements of stakeholders, nothing but this generation and the same transmission distribution. These different stakeholders and different elements are implemented in the smart grid system. The key includes central and decentralized stations, renewable and non-renewable energy power plants, and grid automations. That is intelligent substations, smart switches, and distributions of automations. So far, it is a spread over the generation and transmission and a distribution of end user or demand side section. Also, power grid system also is different one of the key elements of smart grid system. Create to new opportunity and capability by application of digital technology, that nothing but IoT. The application of intelligence controls and enhance the grid reliability and flexibility, cost efficiency, and also this system safety. Also, we are one of the key elements in the stakeholders, and also enable the consumers to control the both consumption and the generation of powers in one of the key elements of the stakeholders. The blockchain technology. The blockchain technology now, these most of the smart grid systems are implemented. In smart grid in smart grid system, the blockchain technology is made up of distributed ICT tools that support the decentralized structure of local energy market, and also they facilitate the direct interaction between a user in a blockchain based local energy market, that is a consumer, who are both consumer and a producer in the system. You can trade to electricity without intermediates. So these blockchain, the marketplace, they represent the smart contract with the accept order from all participants of blockchain, and performs a merit order mechanism for efficiency of allocation of powers. So these blockchain integrations enhance the transparency of and the security in smart grid operations, and also ensure the secure data transmission between different entities, power plants, and consumer entities. Decentralization, nothing but reduces the need of decentralized authority by distributing the control among the various modes of grid. The security, the point of security is there is equality, private markets, debit, and there is derivatives. The security sites we are facing. This one of the that are implemented. Digital currency, e-commerce, P2P lending, remittance, global payments, and microfinance are digital currency are the implemented the blockchain technology. And then recording, point of view, recording keeping, healthcare system, this other voting, and this also. Integration, decentralization, energy trading by payment. Energy trading by one of the point of view, energy trading also the blockchain technology. Nothing but energy. What is the energy trading means? There's nothing but real-time energy trading and settlement through smart centers. Reduces the delays and administrative cost in transaction, and this followed by the energy trading and the payment process, and improved the grid management. This grid, one of the important aspects, enables the dynamic optimization of energy flow and resource through automated and secure the decision making process. So this support integration of renewable energy sources, that is nothing but better tracking and verification also improve the grid management system. Grid automations, there's nothing but enhance the functionality of automated system within the grid, ensuring the reliable and secure and data communications through distributed components. And distributed ledger, there is the track and records every transaction within the grid. So for the creating the transparent and record of energy usage from distributed and also payment. This one. In the impact of sustainability, environmental benefits, economic benefits, and the social benefits that reflect the sustainability of the smart grid system. This environmental benefits, now the smart grid system reduces the carbon emissions, efficient energy distribution to reduce the fossil fuel based on the backup system, and higher penetration of renewable energy sources, and minimize the energy losses also. The smart grid system is reduced the transmission distribution losses through the real-time monitoring and optimization also. And decentralize decrease the waste, that is enables the better resource of allocation of reduced, there is a overproduction of electricity. Even in the economic point of view, the energy cost also savings. That is a dynamic pricing and encourage off peak usage and reducing the energy cost. Nothing but this optimized energy use, lower operational expense for utilize and also consumers. and job creations, development of maintenance of smart grid infrastructure, create the new employability opportunity for new the young engineers. In point of view, in this impact the sustainability in the point of view social benefits, energy access and equality. There is a smart grid can extend the electricity to unserved region by optimizing the resource distribution, and enhance the reliability. This is nothing but this reduce the frequency but the duration of power outage. That is nothing but duration of power outage. The consumer point of view, the consumer empowerment, this real-time data demand response. That is nothing but allow the consumer to make informed decision about the energy consumption. That in point of social benefits. Which this in case of the future trends in smart grid, there's artificial intelligence and machine learning. So we are interconnected with the smart grid system. The optimizing the grid performance for predicting the maintenance work. That is a fault calculation, fault maintenance, and other different kind of fault. We are in a related with the fault. Immediately we are find out the smart grids using AI in ML learning system. The decentralized energy system increased the microgrid and the community-based energy solutions, and IoT and smart device were enhanced the consumer integration with the grid smart and the home appliances, and home devices also. Integration of artificial intelligence and AI machine learning system. The integration of artificial intelligence and machine learning system to transform the grid. They have electrical grid to operate new technology. They enable the real-time applications and improve the decision making and predictive capability, leading the enhanced grid reliability. That is nothing but say efficiency and increase the efficiency using new technology. And the dynamic energy distributions to the AI operates and used for the distribution of electricity based on real-time demand and supply the data from utility to grid to utility. And also balancing, load balancing. The load balancing also maintained by using ML algorithm and detect imbalance between the grid and redirect power flow to the prevent outage. Ensure the unbiased energy delivery to higher demand areas without overloading the infrastructure using load balancing. The reducing the grid efficiency, reducing the energy losses. So far, grid efficiency also increased. Grid efficiency also increased. There is another followed by the optimization of grid performance. The different kind of optimization key features are employed for smart grid system, predictive maintenance and load forecasting, energy efficiency, fault detections and isolations, renewable integrations, grid subsidization, smart grid automation, optimized energy distribution, demand response, and a new technology, advanced energy storage system. The different kind of automation performance are followed by the smart grid system. The latest research on hybrid smart grid system. The different kind of topics, latest researchers are going on to analyze the smart grid system to new technology development to improve the smart grid hybrid system. So for focusing advanced technology, improving the efficiency and ensuring the sustainability. And it extends the various disciplines to include the electrical engineering, computer science, renewable energy, and the policy sites. They are used for researchers. The new researchers are coming to the society. So for the system integrations, this to integrate the renewable energy source traditional power system and energy storage into the undefined grid. There is a grid. In the system integration point of view, system integration, the new topics are optimal sizing and integration of renewable energy system within the hybrid grid. Integration of distributed energy resource in the existing grid. This suppose the another one important topic, the new research topic in this hybrid system, strategy for hybrid microgrid integration with the central grid. This is one of the my scholars are joined this time in this field, doing the research in the field. Strategy for hybrid microgrid integration with the central grid. And smart grid technology, in point of view, smart grid technology develop the smart technology for monitoring, communication, and control. They are implementing. And this smart grid technology, advanced sensor and IoT device for real-time applications and data acquisition system combined with the smart grid technology. Development of new communication protocols and algorithms also develop using these these smart grid technology. And new nowadays the AI, artificial intelligence and machine learning for analytics data and energy forecasting to the smart grid technology. And then energy storage system, point of energy storage system is another important research topic in this energy storage system. This development of high capability and low cost batteries, batteries is developed, and then research of novel storage technology like batteries and supercapacitor and hydrogen storage system are used for new energy storage system. The energy management, from the point of view, energy management and optimization and flexibility point of view, this optimize the energy generation, distribution and consumption. This that is nothing but load balancing and big peak load savings using demand side management, DSM, demand side management. The algorithm for new algorithm, developed new algorithm for dynamic pricing and energy trading. This energy trading and the dynamic pricing to develop the new algorithm. So the real-time optimization and the power flow in hybrid this energy management system. And then flexibility and reliability point of view, the fault and the self-healing mechanism, this energy grid robustness and cyber attack for neutral resource. So for development of controlled strategy for hybrid and microgrid system, in environmental point of view and the employment point of view, is a new technology or employment aspects. Are the research some topics are life cycle analyze for hybrid and grid components. And the economic models for hybrid grid deployment in urban and rural areas. Some policy framework for increasing the renewable energy integration to improve the power generation system. The advanced power converters, in point of view, advanced power converter, development of bidirectional inverters for hybrid system, design of controls for operation of AC and DC system, high efficiency converter for design to high efficiency power converter for interconnecting the new renewable energy storage system. And in point of microgrid, islanding and the grid recognition strategy, multi microgrid coordination and energy sharing topic, and the different standards for microgrid protection and interlocking system. Interlocking system. What are the different research tools? The different kind of research tools. Research tools and methods are applied for the smart grid installation system. Simulation platform like that all are well known, the MATLAB simulating model and a PSCAD. And the Homer is one of the new software system for integrating the smart grid system. And the PV system, another one software for solar design smart grid. And then in point of view hardware, in loop system, HLD system, real-time testing and hybrid components and system. Experimental prototype, the development of new prototype model called the hybrid grid and control environment. Future direction. This development of hybrid grids powered by 100% renewable energy. This already we have discussed the blockchain technology for decentralized energy trading system. This quantum computing for solving the complex integration of problems. And then new AI power tools or automated grids are employed for this future directions to install the smart grid system. A lot of governments, a lot of funds are all permitted to the Indian governments to install the smart grid system. And also some lot of research proposals invited to install the smart grid system, new technology development. So for most I'm
Completed, Professor.
yes, Professor.
Thank you for your timing.
Okay, and I have completed. Any questions related with the topic? Please raise questions.
Participants, please raise any questions on your side.
The latest technology, some future researcher is doing the research and smart grid decentralization, smart grid highlighting the smart grid.
Oh yes, good, Professor. Any questions? Professor, shall we go for vote of thanks?
Okay. Now, Professor, now I thank to Dr. Saravanan sir for coordinator to conduct the online FDP program. And also I thank to Dr. Professor Sivaganesan sir, my colleague and also co-coordinator, the Department of EEE for coordinating this Atal FDP program. Thank you for giving the opportunity for expanding the smart grid system in this FDP program. Thank you, Professor. Thank you.
Thank you, Professor, for your valuable time and then useful informations.
Okay.
What shall we wind up the session? Rajesh, ma'am, please hand it to the please carry on the vote of thanks.
Okay, sir. Good evening, everyone. I'm Rajeshwari. It is my privilege to propose the vote of thanks on this remarkable occasion. First and foremost, I would like to express our heartfelt gratitude to the speaker, Dr. N. Shanmugasundaram, for their insightful and inspiring keynote address. Your expertise and valuable thoughts on the integration of wind power and smart grid technology for sustainable development have enriched us immensely. I would also like to acknowledge the unwavering support of AICT Atal for making this event possible. Your commitment to advancing education and innovation in sustainable development is truly commendable. A special mention to all the participants for their enthusiasm, interactive engagement, and insightful discussions throughout the sessions. It is your involvement that has made this program a great success. Let us all carry forward the lessons learned here and work together towards a sustainable future powered by innovation and collaboration. Thank you all once again, and I wish you continued success in your endeavors. Thank you very much, sir, for giving us valuable information.
Thank you, ma'am. Thank you.
Thank you, Professor. We are so happy about that. Given a wonderful session with us. I'm happy about that. I also did my research PhD in Welsh University only.
Yes, Professor.
The mother of our things. I'm so happy about that.
Okay.
Thank you for your
Three,
valuable
my 3-4 scholars are doing this same field, research in same field, smart grid system.
Okay,
Smart grid system.
excellent, professor. Excellent.
Thank you.
Yeah, we please the gratitude of your speech about that.
Thank you, Professor. Thank you, Professor.
Thank you, professor.
Okay. Now I end up.
Yeah, yes, professor.
Thank you.
Thank you very much, professor. Saran sir will call you. Please, participants, please fill the feedback form we placed in chat box. So, sorry, we understand that today we received a lot of queries regarding attendance. Actually, we are merging with Google as well as feedback form. That's why we are getting delay. Please understand our situations. Thank you. Thank you for your valuable time. Please fill the feedback form. Thank you. Have a great day.